All right, now we're going to do some examples that involve all three things. We still don't have a phase shift. They never gave you one with a phase shift, so I'm not going to worry you with that. But we will have an amplitude change, a period change, and a vertical translation, and we'll take a look at what would happen. Let's start by identifying the things they wanted. Our amplitude, again, is the number multiplied directly in front of your function. So here 3 cosine. So our amplitude is the absolute value of 3, which is just 3. The period, again, for cosine is normally 2 pi in length. The only time that changes is if you have something multiplied by your x, which we do. It's multiplied by a 2. We divide our normal period of 2 pi by that number, and that gives us a new period of pi. So now it's only going to take us from 0 to pi to get through one full cycle. Vertical translation happens when you have something added or subtracted from your entire function. And here we have a minus 2 here. So our vertical translation will be down 2. And there is no phase shift. Again, you would notice that if there was something added or subtracted with our x, but there's just not. So there's no phase shift. So my graph, I know, is going to kind of be shortened up here because I have a shorter period. Okay, so I'm going to stretch pi out just a hair so that I have enough room to draw everything. So I know I'm going to be going from 0 to pi because there was no phase shift. I can still start at 0. Check for any reflection. There's no reflection. If there were, it would be a negative number multiplied by our cosine. So we're still going to start up at the top of our amplitude. Okay, what is our amplitude? It's 3. Okay, has our midline changed at all? Yes, we're going to have a vertical translation of negative 2. So instead of our midline being at the x-axis at 0, it's going to be here at negative 2. And like I said, I like to put a little dotted line there. I will take it out later because it's not actually part of the graph. It's just something that I use when I'm graphing to help me know kind of where my midline is. All right, so then let's make sure we have the points we need for our amplitude. Okay, so our amplitude is 3, so we need to end up 3 above the midline. So up 1, 2, 3 above the midline would be up at 1. That's going to be at the tops. And 3 below the midline, so down 3 from the midline is going to be our bottoms. Negative 3, 4, negative 5 is going to be our bottom down here. Okay. The next thing I like to do is kind of section off my middles. So halfway between 0 and pi would be pi over 2. That's going to be the middle of my period. That's going to be when I hit my bottom for cosine. But I also need the quarter marks, so 1/4 of the way and 3/4 of the way, because at cosine that's when you come back to the midline, and I need to know where those places are. Now the numbers for those, notice I have a full thing. It's broken into fourths. This would be 1/4 pi, or pi over 4, and this would be 3/4 of pi, 3 pi over 4. Okay. I'm going to again change ink colors to draw my actual graph so that we can see it a little better. We'll go back to red here. Okay, so cosine starts up at the top of its peak, okay, at 0, and again we've had no phase shift, so we're going to start up at the top of our peak at 0. Then we know 1/4 of the way through we need to be back at the midline. So here was our midline again. That's why I put that dotted line so I could tell where it was. And then halfway through, we need to be down at our lowest point. Okay, so down here, down 3 from the midline. 3/4 of the way, we need to come back to the midline. And then all at the end of our period, we need to come back to our peak, which was supposed to be up at 1. That gives me kind of an outline. I want to make sure these are curves and not straight lines. We don't want a V there. We need to have some curve to it. It's tough because it's so squished, but put as much curve into it as you can to make it look like a cosine function. Okay, so it looks like a reindeer. All right, so here we go. That is one period of cosine. Again, it would repeat as we continue this direction and as we continue this direction, but this is one period, what it would look like. So notice it's taller because it had an amplitude of 3 instead of 1. It's moved down 2 from where we were, and it's kind of shortened. It's only a period of pi, so we get where we're going faster. I'm going to now erase my help guide that I put on there because that's not part of my graph. It was just my little helper. Okay, and there's my graph. All right, now let's take a look at another sine example, and I put my example of sine up here because this is going to be a really long one. It's going to be very stretched out. So let's start. Here is our function. Let's start by identifying what we have. Now, first thing I notice is in front of sine is negative, so I know this is going to be reflected. I want to note that. Even though they don't tell me to, I'm going to because I don't want to screw up my graph. Okay. The amplitude, again, is the number that's multiplied in front there, the absolute value of that. So the absolute value of -4 is 4. The period, well, the normal period for sine is 2 pi, but notice we have something multiplied by the x. So to find our period, we divide by that number. Again, when you're dividing fractions, what you do is you flip that bottom one and you multiply. But what that does is my 2's cancel here, and I get 5 pi for my period. Okay, so wow, notice that's quite a bit longer than it was. So our period is going to be 5 pi long instead of just 2 pi long. That's why I left a lot of space here on the bottom so that I could stretch that out. If you multiplied, you get 10 pi over 2, which is 5 pi. Okay, vertical translation. So anything added or subtracted? Yep, I have a positive 3 here. So I'm going to be moved up 3. And phase shift, again, nothing was added or subtracted from the x, so there's no phase shift here. We have all of our info. It's reflected. The amplitude is 4, the period is 5 pi, and it's a vertical translation of 3. So let's give ourselves a little start here. All right, so there's my axes. I want to stretch this out as far as I can. All right, good. What do I need? I need to know where my midline is going to be. It's normally at 0, but since we had a vertical translation of 3, it's going to be moved up 1, 2, 3. So here's my midline, which I will erase after I'm done graphing this, but I need it. Okay, so there's my midline. Then I look at my amplitude is 4, so my peaks are going to be 4 above that. Okay, which would put me at 7, and 4 below that. So 1, 2, 3, 4. So at -1 is where I'm going to hit my lows. The next thing I want to put is my period on there. So my period is 5 pi. So I'm going to go in pi's here. So here is pi, 2 pi, 3 pi, 4 pi, 5 pi. Okay, I want the middle of that. Well, halfway between 0 and 5 is, well, if I took 5 divided by 2, is 2.5. So my middle, because remember we kind of have sections here, we hit our peak a fourth of the way through sine, come back to the midline halfway through, and then hit another at 3/4 of the way through. Okay, so we need our middle first, and like I said, that's at 2.5, so it would be right here. Okay, which would be 5/2 pi. I'm going to mark that out so I know where it is. That's my halfway mark. My axes are off a little bit, we can tell. All right, so then halfway between those, each of my fourths, okay, that is where I'm going to have my peaks. Okay, so to find exactly where that is, what you would do is you find the average or the middle. Okay, so I go 5/2 plus 0 is 5/2, and you divide that by 2, because remember, to average something, you add them together and divide by 2. Okay, so 5/2 plus 0 is 5/2, divided by 2 is 5/4. So 5 pi over 4, which would be where? Okay, so here's pi over 2. Okay, 5 pi over 4 would be just past pi. It's 1 1/4 pi. Okay, and notice that does look like it's about halfway there. Okay, my quarter mark here, so I want halfway between 5 pi over 2 and 5 pi. So again, to find that exact place so that you can label your axes completely and clearly, we're going to take the 5 pi over 2 plus the 5 pi and divide by 2. That's how we average things. Okay? Well, when we do that, 5 pi over 2 plus 5 pi is 15 pi over 2. If you divide that by 2, you get 15 pi over 4. So 15/4 pi. Well, where would that be? 15/4 is 3 3/4 pi. So here we have our, I should probably put all my halfway marks in there. Here's halfway. Okay, we want 3 3/4, so right here. Okay, so that's 15 pi over 4, and it's right there. Okay, and then here's where my periods end. Notice I have that marked out in fourths. So, my sine function starts at 0. Normally it goes up to its peak, but remember this was reflected because of the negative that was multiplied there. So we're going to go down. We're going to start at 0 on our midline, going to go down, reach our lowest point, which is 4 below the midline at 5 pi over 4. Okay, we are going to come back up to the midline halfway through, which was 5 pi over 2. We're going to go back up and reach our peak 3/4 of the way through, which was at 15 pi over 4, and then we'll come back down at 5 pi. Okay, well, let's draw our curve. So notice it's been reflected. Double check that. I'm going to again change my ink color so I can see my graph as opposed to all my markings I used to help. So we go down 3 from the midline, 1/4 of the way through, there we go. We come back up, reach the midline halfway through our period, come back up, reach our peak 3/4 of the way through our period, and then come back to the midline at the end of our period. And again, this would continue the pattern, but they just asked for one period, so that's all that I have graphed. And now I'm going to come through and take out all these guidelines that I used to make sure that I had everything in the right spot. And then I would probably spruce up my axes down there because it's kind of looking pretty ugly. Take all the midline out, okay? Because this is not actually part of my graph. It's just kind of a scaffolding that I used to make sure it was all written out correctly. Okay, so then I would also probably come back down here and label my axes a little better. So I have pi over 2, pi, okay, this would be 3 pi over 2, 2 pi, 5 pi over 2, 3 pi, 7 pi over 2, okay, and you get the idea. All right, so that is a full period of 3 minus 4 sine 2/5 of x.